Good morning, students. Now let us see the second lecture of solid state. Now we'll move to the point known as lattice. Lattice means a regular arrangement of constituent particles in 3D. 3D means in three dimensional, or you can write as regular arrangement of points is called lattice. Let us see some constituent particles I am drawing. I am joining this constituent particles C. I'll get a cube, and when I'll repeat it, Cl. Again I will get a cube. Once more if I will repeat it, say I will get a cube. So regular arrangement of these constituent particles in three dimensional is called as lattice, and the single point, this point is called as lattice point. Okay, got it? Okay, so this continuous repeating pattern will form a single crystal, and the smallest part of this is called as unit cell. Let us take an example of the sugar which you eat. You see that sugar is cubic, but that single sugar cube is formed by fusion of many cubes inside. We cannot see it. Small cubes are there, and the smallest repeating part of that cube is called as unit cell. Now let us see some types of unit cell. On the basis of angles and axis, there are about 7 type of crystal system. There are 7 type of crystal system and 14 types of Bravais lattice. Now what is this Bravais lattice? Further we are going to see what is this Bravais lattice. But before that, some basic things we'll see it. Now whenever you see the first one, I have written there simple, or it is called as primitive, or it is called SCC, simple cubic crystal. What is simple cubic crystal? Students, please see here. Look here, this is a cube. If 8 constituent particles are at 8 corner, what I am saying, if 8 constituent particles are at 8 corner, this is called as SCC, simple cubic crystal. Say once more, simple cubic crystal. Here 8 atoms are at 8 corner, 8 constituent particles are at 8 corner. What is this constituent particle? Once more I am repeating, constituent particles means it can be atom, it can be ion, or it can be molecule. Okay, now once more I will draw SCC. If you see the 8 constituent particles at 8 corners, it is called as SCC. What is this points I am giving? This is actually the center point of the circle. Here it is a circle. Okay, just let me draw once more. One, two, three, 4, 5, 6, 7, and this is the 8th one. Okay, now this is the center point of this circle. Everywhere there is a circle. So how much circle belongs to this crystal or this unit cell which I have shaded? This much part. Okay, if I draw a circle here, so see students, only this much part belongs to this unit cell. So if I'll say this is first part, second, third, fourth. Okay, and as you know, this molecule is 3D. means backside also how much parts will be there? Fifth, sixth, seventh and eighth. So how much part belongs to this circle? Sorry, this unit cell only 1/8. How 1/8? This 1, 2, 3, 4, backside 5, 6, 7, 8. Only 1/8 part belongs to this unit cell. And like this, how many circles are there? You see 8 constituent particles are at 8 corners, means like this 8 circles, means 1/8 of 8 is 1. Okay, once more I will explain you. If I draw a circle, if I'll make the 8 parts of that circle, if I draw a circle, and downside I'll draw a cube. When 8 constituent particles are at 8 corner, 8 constituent particles are at 8 corner, you will say it as SCC. So how much part of this circle belongs? 1/8. Means this circle will occupy only this much. And the second one, third one, fourth one, fifth one, sixth one, seventh one, 8. So by mixing the small part, we'll get a complete circle. Means 1/8 of 8 is 1. That means 1 means we'll get a complete circle. Okay. Now let us move for the next one, that is called as BCC. The full form of it is body center cubic crystal. Repeat with me, body center cubic crystal. Let us see. Once more we'll draw a cube. You also draw with me. One, 2, 3, 4, 5, 6, 7, 8. 8 are at 8 corners and 1 is at the center. 8 at 8 corner means it will be SCC, simple cubic crystal. 8 at 8 corner plus 1 in the center means it will be BCC, body center cubic crystal. As you know, the contribution of the corner 1/8 of 8 and the center will not be shared by anyone. So plus 1. So 1/8 of 8 is 1 plus this 1, total 2. So how many circles will be formed out of this? That is 2. If they will ask you what is the rank of BCC, you will say 2. And if they will ask you what is the rank of SCC, you will say 1. Okay. Now let us see the next one, that is FCC, that is face center cubic crystal. Face center cubic crystal. Okay, how to draw face center cubic crystal? You draw a cube, put 8 constituent particles at 8 corner. Eight constituent particles at 8 corner. Now cube is having how many face, students? Tell me, how many parts does cube have? Cube are having 6 face. You might have played the game Ludo or snake or a ladder. There are 6 face. This is the upper face, this is the lower face, this third, fourth, back, and this is front. Okay, now this corners, as you know, this is 1/8 of 8 and this face center only. Now this is the, if this is the circle, half of the circle belongs to this unit cell and half belongs to the upper unit cell. So only contribution is half, and like this faces are 6. 6 face it is having. So 1/8 of 8 is 1 plus 1/2 of 6 is 3. Total how many circles will be formed? 4. So if rank for FCC is asked, you will say fourth. So let us once more revise. For SCC, rank is 1 because 8 constant particles are at 8 corner, and the contribution of one circle for that unit cell is only 1/8, and total circles are 8. So 1/8 of 8 is 1. For body center, 8 constant particles are 8 corner and 1 is at the center. The contribution of the corners are 1/8 of 8, and the center will be not shared by anyone. So plus 1. So 1/8 of 8 is 1 plus that 1, total it is 2. So for BCC rank is 2. For FCC, students, for FCC, face center cubic crystal, 8 are there at 8 corners. So 1/8 of 8 is 1 and 6 faces are there. So and the contribution for that unit cell is half. So half into total 6 face, that is 3. So 3 plus 1, there is 4. So rank for FCC it is fourth. Okay, now let us move to the next one, that is end center ECC. End center means what? Let us draw a cube one more time. You also draw with me. 8 constituent particles are at 8 corner, and only we have to put on the end face, means this is upper face and this is lower face. As you know, corners 1/8 of 8 and face how much? Half. Total face we have taken 2. So 1/8 of 8 is 1 plus half of 2 is 1. So rank of ECC is 2. Okay students, now let us see one more special case, that is called as hexagonal. Okay, I'll try to draw the hexagonal. See, 1 2 3 4 5 6. Okay, like a benzene ring. Okay students, so we'll draw one more. Three, 4, 5, 6. We'll just join it. Okay, so this is hexagon. 6 upside, 6 downside constant particle, and 2 at the face. This is upper face and this is lower face, and 3 in the center. 1 2 3. Now if I draw the circle here, this much belongs to this crystal. How much belongs? You just see, this is circle, and from here this much part belongs. Now if you see, the angle between this is 120, and you can see half of the circle is not occupied, so it is 120 and circle is actually 360. So how much part? 120 120 120 means total 360. 3 part of the half circle and 3 part of upper circle, so only 1/6. How much students? Only 1/6, and total circles are 6 6 sorry total constituent atoms are 6 on the top, 6 at the bottom. So there is 12. So 1/6 of 12 is how much? 2. BCC, how many points I had put in center? 3, and it will be not shared by anyone. So plus 3. And how much constituent particles I have put on the face? There are 2. And you know, in face how much contribution is there? Half. How many face are there? 2. So that becomes 1. So this is 2, 3, and this is 1. So total 6. So if it is asked what is rank of hexagonal, you'll say 6. 6 hexa. 6 hexa means you can easily remember it. Okay. Now we'll go to the 7 type of crystal system. Here I'll give a very nice small trick so that you will remember all these 7 kind of crystal system along with its age length, angle, and you will also remember 14 types of Bravais letters. So students, please pay attention and see this trick. Okay, now I have made one short cut that I'll show you. Just a minute. Just a minute, students. I lost the connection. Okay. So, okay. Now see, the short trick is C T O R H M T. You'll remember this word. You'll say C Tor HMT. C Tor C Tor HMT. So what is this C? C means cubic. T means tetragonal. O means orthorhombic. R means rhombohedral. H means hexagonal. M means monoclinic. And T means triclinic. So once more we'll try to remember it. C Tor HMT. C Tor HMT. C means yes, cubic. T means tetragonal. O means orthorhombic. R means yes, rhombohedral. H means hexagonal. M means monoclinic, and T means triclinic. So it is C Tor HMT. Yes, students, C Tor HMT. Now I will tell you some trick to remember its age length. For cubic, you'll write A is equal to B, B is equal to C. All the ages are same. You know, volume of cube is L cube. So instead of L, we are putting the notation A. So volume of cube is A cube, which I already mentioned upside. So we have, instead of A cube, we have written A, B and C. So if all the edge length are same, means it is cubic. Second, you will remember A is equal to B, B is not equal to C. And third one, A is not equal to B, B is not equal to C. Okay, see the trick. First I have written A is equal to B, B is equal to C. Second, A is equal to B, B is not equal to C. Third one, A is not equal to B, B is not equal to C. Then again you can repeat from first, that is A is equal to B, B is equal to C. A is equal to B, B is not equal to C. A is not equal to B, B is not equal to C. Only one is left. Again the last one you have to repeat, that is A is not equal to B, B is not equal to C. Did you understand it? The first one, A is equal to B, B is equal to C. Second, A is equal to B, B is not equal to C. The third one, A is not equal to B is not equal to C. Now fourth one, again we have to repeat, A is equal to B is equal to C. The next one, A is equal to B is not equal to C. And the sixth one, A is not equal to B is not equal to C. And the seventh one is left, so the sixth one only will repeat it. A is not equal to B is not equal to C. Okay, now same way I'll show you trick to remember its bond angle. So again I'll write C tor HMT, C tor HMT. For the first angle you need to remember, alpha is equal to beta, beta is equal to gamma, gamma is equal to 90. First three will be same. Alpha is equal to beta, beta is equal to gamma, gamma is equal to 90. Again, alpha is equal to beta, beta is equal to gamma, gamma is equal to 90. Okay, the fourth one, it is little different. Alpha is equal to beta, beta is equal to gamma, but gamma is not equal to 90. Okay, so there is only slight change. Alpha is equal to beta, beta is equal to gamma, gamma is not equal to 90. Okay, we have finished 4. Now fifth one, you see, alpha and beta is equal to 90 and gamma is equal to 120. The next one, alpha and beta is equal to 90 but gamma is not equal to 90. And the last one, alpha is not equal to beta, beta is not equal to gamma, and gamma is not equal to 90. Okay, did you understand the angles? Once more I'll repeat. You can say behind me. First one, alpha is equal to beta, beta is equal to gamma, gamma is equal to 90. First three are same. So second one, alpha is equal to beta, beta is equal to gamma, gamma is equal to 90. The third one, alpha is equal to beta, beta is equal to gamma, gamma is equal to 90. Fourth one, alpha is equal to beta, beta is equal to gamma, but gamma is not equal to 90. The fifth one, alpha is equal to beta, beta is equal to 90 but gamma is 120. Sixth one, alpha is equal to beta equal to 90 but gamma is not equal to 90. And the last one, alpha is not equal to beta, beta is not equal to gamma, gamma is not equal to 90. Now we'll see what is short trick to remember Bravais lattice. Okay, so once more I'll write here, C tor HMT. The trick here it is the third one, that is orthorhombic. Here you will write 4 4 3 2 1 1 2 1. What? 4 3 2 1 1 2 1. See here, C tor HMT. Here you need to start 4, then 3, then it is 2 1 1 2 1. The first one, cubic, the number is 3, means it is of 3 types. What are these 3 types which we already learned before this? That is, first was SCC, second was BCC, third FCC, and fourth ECC. SCC means simple cubic crystal, BCC means body center cubic crystal, FCC means face center cubic crystal, and ECC is end center cubic crystal. Okay, so we'll go back to our point. C tor HMT. Okay, here I'll write 4 3 2 1 1 2 1. Means this is of 3 types. What is that 3 types? SCC, BCC, and FCC. This is of 2 types. Means what? SCC and BCC. given that sequence, now this is a 4 type: SCC, BCC, FCC and ECC. This is of only one type, means only SCC. This is one type, means only SCC. Only here I am making a star. Here it is 2. You need to remember, out of this, one is SCC and one is the last one, that is ECC. Here I am making a star. First is SCC and then ECC, means end center. And here also it is SCC. Now you just count how much this 3 plus 2 5, 5 plus 4 9, 1 10, 11, 12, 13, 14. So there are how many types of Bravis lattice? There are 14 types of Bravis lattice. Okay, so this is a small trick, and you see in your board book, with this small trick we have covered at least 5-6 pages of your NCERT and board syllabus in this. This is a small trick. So you practice this trick and tell me if any difficulty is there. Okay, students. Thank you.